You would have been too late.
Okay, we need to go over the rest of the answers.
How will you be able to go down if you don't practice for it?
Yeah.
This is the only time I never did.
Oh.
Still,
Yeah,
what if like the staircase changed?
Yeah.
In the past, like,
Because I want to post the correct answers today. Okay, so where do we have to, what do we have to do?
Oh, I have like a super fast question on number 17. C.
can you
Why is there like no y equals thing? There's like an x equals 2 and z equals 3. Why?
That's because if it's going to be perpendicular to the xy plane, that means it's going to be parallel to the y-axis. So it doesn't have any y component. There's no y component.
Okay.
That's why.
But like,
Is that you?
Get a text message. From your wife.
Yep.
You get text on?
Is that the only number that you have on your phone? Your wife's?
His kids.
He has kids?
Yes, he does.
Oh yeah, Jensen Park and
can you look at his face?
Michael Park. No, but he doesn't have any, or her.
Okay, come on. Which ones are we going to go over?
16.
16, which is the...
You're like,
Oh yeah,
Go over
16.
I had no idea what
That
to
made
do.
no sense. I tried to use the diagram we did in class. Yes.
Okay, let's do this. Did you use the dot product?
No.
Wait, I didn't know you should do that.
How do I make this thing smaller then?
Quiz cosine.
Oh, that's right.
But still.
Sorry.
So do you like, you separate the cosine from the magnitude of UV,
Oh gosh, I'm not going to be able to read any of this.
square both
Yeah.
Wait, what are you
sides.
trying to do? Make it bigger?
So I can see it all at once, so I don't have to
Press and
scroll. Okay, you said number 16?
Yeah.
Yes.
Oh, that's the easiest problem.
What?
Well,
Okay, look. This is how easy this problem is. It's ridiculous. Okay, let's say you have a vector right there. And let's say the components are A, B, C. You want to do that then?
yes.
So alpha is the angle it makes with the positive x-axis. So what you have to do, this is alpha. Can you think of a vector that points in the positive x direction?
0, 0, 1.
No,
I mean,
1, 0,
1,
0. Okay, and then here's the positive y-axis. Can you think of a vector that points in the positive y direction?
0,
0, 1, 0. And then what about this one here?
0.
0, 0, 0, 1. And then therefore this is beta, and this, that's gamma, correct?
Yeah.
So how do you find the angle right here? Cosine of the angle is equal to the dot product of the two vectors, so there.
Divided by the magnitude.
So what is the dot product of vector v and this one right here?
A.
A plus 0, right? A over the length of this, which is 1, and the length of that, which is the square root of a squared plus b squared plus c squared, correct? Okay, now what about beta? Cosine of angle beta is equal to the dot product of vector v with this, which is b, over the length of this vector, which is 1, and the length of that vector, which is the, you guys see it now? And then finally, what is the cosine of gamma? The dot product of these two vectors, which is c, over the length of this one, which is 1, and the length of that one is the square root of a squared plus b squared plus c squared. Now, the question is asking what is cosine squared alpha plus cosine squared beta plus cosine squared gamma? But come on, look at this. Square both sides, square both sides, square both sides, add them up.
Oh.
What do you get? Cosine squared alpha plus cosine squared beta plus cosine squared gamma equals, what is this plus this plus this? Rhymes with 1. 1, boom,
Wait,
finish.
how do you know to find the positive or like positive vector?
No, it doesn't have, A, B, and C don't have to be positive numbers.
No, but I mean like the 1, 0, 0 and 0, 1, 0.
Because you're trying to find an angle it makes with the positive x-axis, so that's why you gotta find a vector that points in the positive x direction. Now, you don't have to pick 1, 0, 0, you can pick 2, 0, 0, or 5, 0, 0. But isn't it a lot easier to We'll make it 1, 0, 0, that way the length of it is 1. You can pick any vector that points in that direction. Okay, next. Some people had a question on number 17. 17 what?
C.
Cho, are you checking all the answers are correct?
Oh, yeah.
So 17 what? Huh?
C.
17C. 17C, I gotta read the problem. Write the equation of the line that contains, isn't this what the Wang was asking?
Yeah.
Look, come over here, I cannot even read. Pass this through to what point?
2, negative 2, 3.
2, negative 2, 3. 2, negative 2, 3. And it is perpendicular to the XZ plane. Okay, look. When in doubt, draw a picture. What is the XZ plane? Isn't it this one right here? Okay, so if it's going to be perpendicular to that, like that, doesn't it have to be parallel to the y-axis?
Oh.
Yeah, so that's why it's got to be parallel. So what do you need? What do you need to write any? What are we writing an equation of a line? What are the two things you need to write an equation of a line?
So then,
You know, there's no slope in 3 dimension. You need a point and a vector that points in the direction. So what vector points like that in the positive y direction like that?
0,
0, 1, 0. Okay, so there, therefore what is it?
1, 0. X.
So x equals 2 plus 0t. Y equals negative 2 plus 1t. Z equals 3 plus 0t. Boom.
Wait, yeah, that's what I have, but then like, how can you just like, I understand like theoretically how you can get rid of the y one, but then how can you just like get rid of it in the equation?
Well, what's the answer on the bottom?
It doesn't have the negative 2 plus t.
Well, let me see. Next, 17c.
Or does it? I don't know.
17c. X equals 2, z equals 3. Isn't that the same thing?
Well, like, there's.
Yeah, x equals 2 and z equals 3.
No, but like.
What'd you do with the y?
Yeah, that's a.
Because y can be anything.
But then, how do you know you can just get rid of that, like,
Yeah.
equation? Wait,
Oh, y could be anything because parallel.
yeah.
Oh.
Because you cannot solve for t in these two equations. Because normally what we do to put it in rectangular form is we solve for t, solve for t, solve for t, and equate them, right? But you cannot solve for t in these two equations.
Oh, so like, so y could just like theoretically, or because t could like theoretically be anything, then y can be anything.
Yes. Yeah. Okay, so that's 17c. Okay, anything else in number 17? Okay, you guys gotta tell me.
19.
19.
Is that,
What?
wait, is that, you just have to do like. d-
Okay, here, let me outline, what the heck, let's just do it to make sure the answer is right.
What number?
Number 19. I don't know if you guys remember or not, but this problem was on the PCH test.
The final?
Find, no, on the vector
I
exam.
know.
Find the distance between the point, can you read the point to me?
1, negative 2, negative 5.
And,
The line x minus 1 over 2 equals y plus 1 over 3 equals.
Yeah, I remember this
2
problem.
Did you read?
over
I don't
5.
think so.
okay, you know what? I'm pretty sure this problem's gonna be on Friday's test. Okay, let's review. How do you find the distance between a point and a line in space?
Oh, the dot.
You draw the triangle, right? So what you do is you find 2 points on the line like this, and what you do is you make a triangle like this. Yeah? Is following?
Why and then what?
So isn't the area of this triangle 1/2
Oh, yeah,
base
yeah,
times
yeah.
height?
Yeah.
Okay, so what you do is you make like these two vectors like this. Okay? So what we're trying to do, the distance between the point and the line would simply be the height of this triangle, right? So we're trying to find the height. So what you need to do is find the area and the base. and just pretty much use that formula. Okay, let's do it. This is exactly the same problem we had in DZH. But because we forgot everything, that's why we're in trouble. Okay, if you know these two vectors, first of all, before we need to do anything, so what you do is find these two vectors over here. So, how do you guys want to do it?
Cross product?
Yeah, it has something to do with the cross product, but what is this vector right here?
Vector.
Okay, look, 1, -2, -5. Okay, somebody tell me, what are the coordinates of, give me a point on this line.
1, -2.
No, 1,
Negative.
-1, 2. How do I know that point is on the line? Because when you plug it in, you get 0 equals 0 equals 0, which is true. Anything that makes that equation true is also on the line. What's another point on the line?
2. Wait, no. 3.
Okay, what did we do to get this point? We make it 0 equals 0 equals 0, right? So how about here, just for funsies, let's pick another point on the line.
3.
-1.
Make it come out to 1 equal 1 equal 1. 3, comma,
2.
2,
7.
7. There you go, see? Those are 2 points on the line.
Oh, so you're just finding 2 points in that.
You don't even need that point there, you just need this point, I
And
guess.
you could find the other.
Okay, so let's componentize these two vectors right here. So this one's easy, componentize that, go. Head minus tail,
0.
0,
-1.
-1, -7. Everybody agree? What about this vector here? Componentize it.
2.
2, 3, 5. Oh, I wonder if that has anything to do with the 2, 3, 5 on the bottom there.
Probably not.
Duh, no, duh. It has everything to do with it. So, you guys even remember, if you know two vectors and they form a triangle, how do you find the area of the triangle? Half the length of the cross product. So what you do is you compute the cross product. So you go I, J, K across the top, 0, -1, -7 there, and 2, 3, 5. Okay, let me call on you guys to do it. So this is equal to, we should be good enough to just fill it in, right? Okay, what is the x component? Part.
-2.
What?
Oh, I mean +2.
What?
What?
Let's go across the first row.
Yeah. Oh wait, no, sorry, -5.
-5
16.
plus 21.
16.
Okay, 16. What is the y component, huh?
4.
0 plus 14, but then negative
Oh,
14,
here.
because it's in the negative position, right? And then Wang is the z component.
Negative
0, what?
3. Sorry. 3.
No,
It's 2.
no.
Wait, 2.
0 plus 2
Yeah.
is 2. Okay, that's the cross product. Half the length of this vector is the area. So what is the length of this vector? The square root of 256 plus 196 plus 4. What is that? The square root of 456? Shall we simplify it or just leave it? Let's just leave it. I'll leave the simplifying to you. So therefore, the area of this triangle is half of that. It's root 456 over 2. Everybody agree?
Yeah.
And that's equal to 1/2 base times height. Now we're trying to find the height because the height is the distance between the point and the line. So all we have to do is figure out the base, but isn't the base this vector right here? Doesn't that vector form the base?
So
How do I find the length of that?
root
Square root of, the length of this vector is the square root of that squared plus that squared plus that squared, which is root 38, right there. So therefore, the height, which is the distance between the point and the line, is simply the square root of 456 all over the square root of 38. Boom. Is that the answer we have on the bottom?
probably simplified.
What number is this?
9.
17, no,
9.
19, 2 root 3. So does that simplify to 2 root 3, Joe?
I don't know.
You're supposed to,
Wait.
why do I even give you guys answers? Okay, let me ask you this, does 38 go into 456?
No.
Yes, it does.
Oh, 12.
Yeah, so that's the square root of 12,
Oh,
which
yeah,
is
it is.
2 root 3.
Oh, yeah.
Anyway, I want you to notice what's going on. So basically, isn't the answer just this divided by this? Where did this come from?
The area of the triangle.
Because these twos cancel out, right?
Yeah.
No, that's not the area of the triangle.
Alright.
That's the length of the cross product. And what is that?
The base.
The length of the base here. So, what do you want? You want to call this vector u and this is vector v? So to find the distance between a point and a line, all you have to do is, what did we just do here? Look at that. If you call those two vectors that. How did we get this?
Cross one. Or I mean.
It's the length of the cross product. So it's u cross v, the length of it, and then you divide it by the length of this vector there, which is vector u. Boom. That's how you find the distance between a point and a line in space. If you want a formula.
It's always gonna be the.
But then u has to be the base of the triangle.
Okay.
That's why when we did it in PCH, I told you guys just draw the triangle and then just go area equals 1/2 base times height and figure out the area and the base and you got the height. That's the way we did it in PCH anyway.
It's always gonna be the numbers under, like 2, 3, 5. As the.
What? Have we forgotten how? Okay, what do you need to write an equation of a line? You need a point and a vector that points in the direction of the line, right?
Yes.
Okay, so what's the equation of this line right here? X equals 1 plus 2t, y equals -1 plus 3t, z equals 2 plus 5t, correct? Remember that?
No, I think her.
Okay, so solve for t in this equation.
Oh,
X minus 1/2.
yes.
Solve for t in this equation.
Y plus 1.
And solve for z in this, and then you equate them. That's the same. This is called the parametric representation of a
I was
line.
asking
Just a
if
part.
the.
Her question was, will that be always 2, 3, 5? But then no, it won't be because if the point is like somewhere like that's further.
Yeah, like
then
that's
it won't
because
be
you
2,
picked
3,
this
5.
point. What if you
Yeah.
pick the point further
It won't
away?
be
Then it
2,
won't
3,
be
5 because
won't be
this is
2, 3, 5. It could be 4, 6, 10.
Yeah,
But can we
It'll be a
just
multiple.
assume that it's, like if we have a new equation and we need to find that, can we just not find the extra point and use the numbers under?
Yeah, yeah.
Oh yeah, that's what I was asking.
Oh yeah, then you can.
Okay.
Okay, I'm telling you right now, this problem is on the test. Okay, next. We need to clear up everything today. Cho, you said there are plenty wrong answers. Now is the time to bring it up.
Oh, boy.
Okay, what about 21? Everybody can sketch the plane? No, you know what? I'm going to do this on the board. I hope you took a picture because I erased it.
I did.
Guess not.
I did.
21, sketch the plane. This is on a PCH. 4x plus 6y. I can't even read this thing.
I'll read it for you.
Plus 2 later. Plus 3. How do I know this is a plane? Besides the fact I told you.
Because it's
Why?
Any equation written in this form in 3 dimensions is a plane,
Yeah.
right?
Yes.
Okay, let me ask you this. You guys think you're good, yeah? Never mind. We just do the problem. We just do the problem. Okay, since we know it's a plane, the easiest way to graph this in the first octet is just to plot the x-intercept, the y-intercepts. What's the x-intercept?
3.
3. So here's the x-intercept. 3, 0, 0. How do you find the y-intercept?
2.
0, 2, 0. And what's the z-intercept?
0, 0.
0, 0, 4. Connect it with straight lines like that and then
Oh.
shade in. Waka, 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 waka. There you go.
That's the answer?
That's the plane cutting into the first octet.
That
You
was
had to do
easy,
this,
that's
we did
all.
this at BZ.
Yeah.
That was a problem.
Okay, that was-
Yeah, it says graph in the first octet.
What is it?
That's where x, y, and z are all positive.
Wait, what about?
Oh, it's a quadrant, but not.
What?
The fourth octet?
Yeah, no, it's
I'm not
because
asking
there's
for the
eight.
graph in the fourth octet. I'm asking for the graph in the first octet.
Yeah, but what is the fourth octet? Or octet? Like,
How many options? There's 8.
Okay,
Yeah.
x, y.
Okay.
The z-axis comes out
I just
like this,
made
right?
sure, 'cause I
Yeah.
forgot.
Okay, 1, 2, 3, 4 on this side of the board. So the fourth octant would be right where the chalk is then.
But what about 5, 6, 7, 8?
It's 5, 6, 7, 8 on the other side of the board.
Okay.
How can you graph on the other?
Yeah, that's what makes it difficult. Look, if I don't say graph it in the first octant, you know what you gotta do? You gotta do all kinds of crazy artistic stuff. Okay, this is the first octant where all three coordinates are positive, right? But what if you got a graph like, what you gotta do, maybe you gotta make dotted lines extending backwards and things like that. That's why when we graph, we try to keep it in the first octant because it's easier that way. You know what I'm talking about? And this is just a plane. You know what's going to happen next chapter? We're going to be graphing hyperbolic paraboloids and things like that.
What a saddle.
Can you just put like negative x, negative z, negative y as well?
No, why? What?
To flip
That's
it.
crazy. Like
That's not gonna work.
To
What?
flip it
Okay,
without flipping it.
in algebra
It's just, like,
1,
flipped it around.
in algebra 1, did they tell you to do this or label this the negative x-axis and the negative y-axis?
No, but like in 3D, just in 3D because then you don't have to flip it, but you.
So it's
Like
like
that.
you're facing the other side.
No,
he said just
no,
negate
That's
so
what
it.
you said to do.
No,
No, that's
so
not what
you
he
negate
said.
the x, so like you see where the x is, you put negative, and then you see where the z is.
So
you put
you're
negative.
looking at
So
it
you,
from a
like,
different
flips-
angle.
Yeah, you're looking at it from like.
The
No,
left.
but it has to be in the same orientation though. You cannot just negate each one, it's going to change.
Yeah, that's what I'm saying. No, but then if you change it, then like
That's not gonna work though.
this
No.
one will be the 8th octave.
No,
I
this
mean,
is the standard way in mathematics to graph. This is standard.
You know what I'm saying?
Yeah.
No, you
It's
know
like
what?
you're turning
A lot
the
of
other
people,
side.
no, a lot of people think we should do it like this. This is x and y, and z coming out like that. That's what a lot of people think.
Yeah, but
Yeah.
But that's
I
not
thought it was-
standard. That's not standard. This is standard mathematics. It's like you're looking into the corner of a room.
Okay.
Okay.
Wait, a lot of people think that?
Okay, Cho, you said there are wrong answers. Now is the time to bring it up because I'm publishing this after this class.
25B.
25B. What?
Or like,
You
I
finish
got a
it.
different.
For this?
Okay, can anybody concur with Cho that 25 is the wrong answer?
I didn't get to it first.
Yeah, I was just.
Okay, somebody read me the problem.
I got you.
25B.
Yeah.
Compute
You read that.
quantity 2i plus j
2i plus j
dot
How can you read it?
Dot.
Far away?
quantity double quantity I minus dj plus k quantity plus
Why don't you just take a picture and
it's
then
double
bring it back
quantity,
to
Mr.
me?
Wait.
Clark.
He said 25B.
Oh, sorry.
Oh, come on. Why didn't I just print it out?
Here, just look at
double
what I
quantity
had.
I minus j. No, I'm telling you.
Okay, go.
Double quantity I
Double
minus
quantity.
I minus j.
I'm
N quantity
Oh.
cross quantity j minus k. N quantity cross.
And quantity?
Where? N quantity like that?
Yeah.
No,
No.
yeah,
No.
cross.
What?
Cross.
No.
Oh yeah.
No,
yeah,
what are you
sorry.
doing here? You're messing it up.
So yeah, N quantity
Double quantity.
times or cross.
Cross.
Quantity I plus 5k.
And quantity.
That's it?
Yeah.
This is just computation. Okay, this vector is like 1, negative 1, 0, right, if you want to change it. This vector here is 0, 1, negative 1, correct? And then we got a cross. So how do you find the cross product of two vectors? You make a determinant. You put I, J, K across the top. You put the components of this vector in first, and then you put down in second. Okay, let's compute that. No, let's just write it like this. You guys gotta get used to it. Okay, X component, Joe. No, you know what I'm gonna do?
0.
You just tell me if I'm doing something wrong. Okay, J gonna be negative 1 minus 0 is negative 1, but then you gotta negate it. And then K gonna be 1 minus 0, 1. Did you guys get that?
Yeah.
And then you gotta cross that with this, which
Yeah, I know
is
that.
0, 5. So how do you do that? You make a determinant. I, J, K. Put this in 1, 1, 1, 1, 0, 5. And that's equal to, okay, so if you cross out the row, 5 minus 0 is 5. 2, 2. 5 minus 1 is 4, so it's gonna be negative 4. And then da da da. 0 minus 1 is negative 1. Boom.
Yeah, I got that.
Okay, then that's correct. Okay, what does the answer say? This is 15b?
Yes.
25.
25.
Oh, 25b? Oh, it's 5, -4 or -1. Okay, there you go. Okay, so that was just pure computation.
He did 26.
26. How do you tell, okay, here, this is a lesson in three-dimensional thinking.
Coplanar. That
What
means
does
touching.
coplanar mean? That
Well,
means they
lining
all
up
lie
plane.
in the same plane.
Oh.
Okay, here, let me tell you, here, I'll just tell you. What number is this?
26.
26. Okay, if you have three vectors, put them all tail to tail. How do I know they lie in the same plane, the plane of the chalkboard, for example? Okay, well, take any two of these vectors. Which two you want to take?
The first.
The first two, this one and this one? Now, what happens if I take the cross product of these two? Don't you get a vector that's perpendicular to this plane according to the right-hand rule?
Yes.
Remember the right-hand rule? Did we talk about that already?
Can you go over again? I forgot it.
The shortest, it's in the video, isn't it?
Yeah, but
Look, the shortest way to go from here to here is that direction. You take out your right hand, you curl your fingers in that direction, so that's why it's pointing that way. Yeah, now I remember, it's in the
okay.
video.
Where did you do
Okay, anyway, the cross product is a vector perpendicular to the plane containing these two, so it's a vector like this then. Okay, now, if this vector, what can you say about this vector and this one here, this third one? They're perpendicular as well, which means the dot product is gonna be
0.
0, that's right. So if you call this vector A, vector B, and vector C, to show that they're coplanar, then the cross product of these two vectors here, dotted with the third one there, gotta be 0.
Isn't that like an area of a thing?
What thing?
Or like a parallelepiped?
No, not yet.
Wait, what?
Yeah, you kind of, except the height is 0.
that's no one really know what it is
Oh,
either.
yeah.
Okay, that's coming up, parallelepiped is coming up.
What is it?
No.
Oh gosh, here we go.
Wait.
So, in problem number, okay, read me the three vectors. 1, 1, 1,
0, 1, negative 1.
0, 1, negative 1,
105.
1, 0, 5. Are these three vectors coplanar? So what you do is, how do you check? You take the cross product of any two. Which two you want to do? The first two?
Yes.
Okay, here's the first two. Find the cross product. So, I, J, K, 1, 1, 1, 0, 1, negative 1. And that comes out to? Negative 1 minus 1. Negative 2? Negative 1 minus 0 is negative 1, but then it becomes 1. And then you get 1 minus 0 is 1. Did I do that correctly?
Yeah.
Okay. Now you dot it with this vector, a third one. How do you find the dot product of these two vectors? You
Negative.
multiply the x components, you multiply the y components, you multiply the z components, add them up, and you get 3. Is that 0? No. They're not coplanar. If the dot product comes out 0, then they are coplanar. So that's why the answer was no, because 3 is not 0.
Wait. Coplanar means that
Lie in the same
they
plane.
lie in the same, the vectors, right?
If you put all three vectors tail to tail to tail, then they all lie in the same plane. That's what coplanar means.
Yeah, but
Just like collinear
Wait.
means lie on the same line.
wouldn't you
right?
just know if there's it's all positive, 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 and there's like one negative, because then it's gonna be like going in the other direction, or no?
I don't think you can tell.
Oh.
You cannot tell.
Wait, why is the dot product zero?
Yeah. Right.
Because, were you here
It's like-
1 minute ago?
Everything is like.
Because when you find the cross
Yeah, I
product
think
of
it's like-
these
I think
two,
it's-
don't you get a vector
It's
perpendicular
it's
to
like
the
whole
plane?
thing, it's like too easy.
That's what the cross product is, right?
Yeah.
So if this vector is perpendicular to the plane, then wouldn't this vector be perpendicular to this one?
Oh, yeah.
Yeah, so therefore the dot product gotta be 0.
Oh, yeah.
How do you tell if two vectors are perpendicular? The dot product is 0. See, we're having difficulties because we cannot remember what we learned in PCH. That's the problem. That's the problem.
Maybe we should take multivariable first before calculus BC.
No,
This is the third
it's just
semester
like, no,
calculus.
you
You
learn
won't know
two-dimensional
integrals.
things first because the formulas are easier, and then we extend them to 3 dimensions. That's what we're doing now.
You take multivariable, then
probably do just about as well on the interface.
Okay, now the question is, to do problem 28 is, what the heck is a parallelepiped? You guys know what a rectangular box is? What are you trying to do, make me swear, is that it? Okay, here is a rectangular box. Each of the faces are
One.
rectangles. They're rectangles. So we call this
Rectangular.
a rectangular box.
Yeah, like
But what if each of the faces were not rectangles? What if they were parallelograms? So opposite faces, see, like in a rectangular box, opposite faces are congruent rectangles, right? But instead of rectangles, what if they're parallelograms? So if the opposite faces are congruent parallelograms, like this, then it's like a box, except it's tilted. You know what I mean? That's
it's
what
like
it
a
is.
very
I'm trying to draw this, God, I'm having a hard time here.
Wait,
I'm not good at drawing, obviously. It's terrible already. Oh my God.
wait, you should have just used your
No,
rectangular
but-
box.
Just a rectangular box, but tilted.
Just tilted with your rectangular box. It's like, it looks like a
Something's
sheet
wrong.
that you throw the
Wait.
beanbags.
Anyway, so if you have a box where the opposite faces are parallelograms, congruent parallelograms, we call that a parallelepiped.
Okay.
Okay? So, if you have, okay, let me attempt to draw it again. Gosh, I'm bad at this. Shoot. Oh, this is a little better. Like that? How's that?
Yeah, it looks good.
Okay, so it's a tilted rectangular box. If you, okay, so here's one of the vertices of it. If you can form these three vectors here, Baguga, Baguga, and Baguga, notice that those three vectors form the parallelepiped. Now, we learned this in PCH, but you guys probably forgot. Let's say you componentize this vector. What do you guys want to call the components? What do you want to call the
ABC.
component?
A, B.
A, B, C. Okay, now componentize this vector. The D, E, F.
Yeah.
Componentize that vector. G, H, I. Okay? Throw them into a tree-by-tree determinant. The absolute value of that determinant is the volume of that parallelepiped. Do you remember that from PCH? Oh, that was on one homework. I put it on my test. I don't know if you guys got it on your test. Okay, so in number 28, it says, okay, Cho,
Huh?
any other wrong answers we need to double check for?
27A.
Okay, somebody read me the problem.
Triangle ABC has vertices A 0 1 0, B negative 1 1.
Wait, okay, slow down here. B what?
B negative 1 1 2.
Negative 1, 1, 2.
Yeah. C 2 1 negative 1.
Okay, and then?
Right.
Write the equation of the plane. Come on! Okay, look. What do you need to write an equation of a plane? You need to have a perpendicular vector
And a point.
and a point. Now, we got 3 points, so we got a point. We just need a perpendicular vector. Now, think about it. If you have these 3 points like this, how can I get a vector?
You get used to.
How can I get a vector perpendicular to this plane? The cross product. So, let's say this is A, B, and C. I think we did this on the video.
Tail minus.
Okay, pick any two of these vectors.
A.
How about A, B, and AC? Componentize them. A, B is what? Head minus tail. Head minus tail.
Negative 1.
Negative 1, 0, 2. Okay, now vector AC. Head minus tail. 2,
0, negative 1.
0, negative 1. If I compute the cross product of these two vectors, I'm going to get a vector perpendicular to the plane. That's what a cross product is. So let's do that. Oh, why did I erase that? Because we've got to come back to that. So determinant I, J, K, negative 1, 0, 2, 2, 0, negative 1, that's equal to, okay, let's do this quickly. 0, 1
Negative
minus 4 is
I mean,
negative 3, so
minus
positive 3, and then 0 minus 0 is 0. What? That's junk.
Yeah, I got that too.
I don't like that.
So wait, it's just dy.
Okay, you know what? I don't like that. I'm gonna change it. I'm gonna change this
No,
problem.
no,
Yeah.
no, no,
Yes.
no,
I
no,
print it.
no,
What?
Just change your
I
numbers.
printed the thing out.
Just change.
I'm too bad. I don't want all of these things coming out 0.
no. Wait, but then okay, wait.
Okay, let's just change one of the numbers then.
Oh,
How come your answers?
Wait, can you just keep going, just to like.
Right?
Okay, so
Yeah.
if this is correct, then this vector is perpendicular to the plane. Therefore, the equation of the plane is 0x plus 3y plus 0z plus d equals 0.
I like that.
How come your answers
Oh, and
are
then D
really
goes
dramatic?
negative.
Okay, so how do I figure out the value of d? Plug in one of these points,
So negative.
which is 1. So d is negative 3. So 3y, what did I just say?
Minus 3.
Minus 3 equals 0. Isn't that just y equal 1?
That's the answer.
Yeah, that's the answer. What does it say?
It was like x minus 3y plus z.
Where? What number is this, Joe?
27A.
That ain't the right answer. Okay, that should be, okay, you wanna keep it then? Y equal 1.
Yeah.
Y equal 1. I don't like so many components coming out 0. Okay, then that's gonna change the answer
27B.
for 27b. Find the area of the triangle. Well, here is the cross product.
3.
Half the length of the cross product is the area of the triangle, right? What's the length of this vector? The square root of 0 squared plus 3 squared plus 0 squared, which is
3.
3. Divide by 2, that's the area of the triangle. 3 halves then. See, obviously, I think it got typed out wrong. That's what I think.
That's so funny.
That's not funny.
P over Q.
Don't worry, I'm gonna change it.
See, no, that's the kind of this is the kind of question that should be on the test.
It will be, but it's not gonna be, believe me, I'm gonna make it all non-zero components. Why would I make it come out to,
Nice
Mercy.
numbers.
okay, we only got 10 minutes left, people. We're in trouble.
32.
32.
Oh, gotta take a picture.
Where? No!
Wait, there's a wrong. Wait, I don't know what. Like, I got a different answer.
Dang, a lot of these answers. Maybe it's just.
I think it got typed out wrong. That's
Why
what
are
I-
there 2 answers?
There can't be 2 answers. Where's 32?
There are.
See, we changed the problem. We changed the problem, that's why.
Oh.
That's why we're getting wrong answers.
Changed.
That's okay, we'll just do it for this then. I gotta try to find the correct one somewhere then, I don't know where it is.
Is this really old?
Yeah, we've been doing these problems for 20-something years. Where does this line intersect this plane? 2x plus y minus 3z plus 6 equals 0. That's okay, let's just get the answer for this problem here. So, when you're trying to find where a line intersects some graph, what form do we want the line to be in?
Parametric.
Parametric form. So can you guys go back to parametric form just by looking at this? X equals
-2. Wait.
3t minus 2. Can you
Oh,
guys
yeah.
do that? Because remember how you do it? You solve for t in each of the equations and then you equate them. So it's like each of these is equal to t. So how do you solve for t in this equation? Multiply by 3 and then subtract 2, right? Okay, what about y? Y equals
-1 plus 2t.
2t minus 1 and then z equals
T minus 6.
t minus 6. Can everybody do that? Take these, plug it in here. So 2 times x, 3t minus 2,
Where is it?
2t plus
Yeah.
plus
Yeah.
1, plus 1.
Oh yeah.
Plus y, which is 2t plus 1, minus 3z, which is t minus 6, plus 6 equals 0. So 6t minus 4 plus 2t plus 1 minus 3t plus 18 plus 6 equals 0. So what does that come out? That's 8 minus 3. 5t is equal to, what is this? -3 negative 3 and 24. What is negative 3 and 24? 21, so negative 21?
Yeah.
So t is equal to negative 21. This is stupid. Who makes an answer coming out like that? Okay, so this is the value of t where the line will intersect the graph. Now to find the point, you gotta plug it in. So what happens when you plug in negative 21 fifths here? Negative 63 fifths minus 2. Negative 73rd fifths. What am I even doing? Okay, and then if you plug in negative 21 fifths there, you're going to get negative 42 fifths plus 1. Negative 37 fifths. And then right here, negative 21 fifths.
Negative 51.
That's going to be negative 21 fifths minus 30 fifths. Negative 51 fifths.
Ew.
Oh.
Yeah, I got
Negative 73rd fifths, negative 37 fifths, negative 51 fifths.
That's a good one for my actual answer.
And then finally, let's just talk about number 33.
Just talk about it.
Yeah, I'm not going to do it.
Is it gonna be?
Because it's easy. Yes, it's on the test. What kind of question is that?
level 30.
Wait, we're still talking about the
Probably,
parallel
yeah.
of
I would say it could have like 10 to 12 problems on the test. Okay,
And we still have the same. We have
okay.
the same one.
Remember the parallelepiped? Now I'm going to try and draw it again.
That's better.
Okay, here's the parallelepiped.
Never mind.
It's like a-
Okay,
it's like-
so these three vectors, don't they form the parallelepiped? And I remember I told you that if you just put the components of these three vectors into a 3x3 determinant, the absolute value of this is the volume, correct? You guys remember that? So what would happen then if instead of finding the volume of the entire parallelepiped, what if I want to just find the volume of, right there, the tetrahedron, which is what you're doing in problem 33.
Oh, it's 1.
So the volume of this tetrahedron right there is what fraction of the parallelepiped?
1, 2, 3, 4, 1, 6.
Is it
Fourth.
8? 1 8.
Okay, I heard three different answers.
One
One,
6.
1/6, 1/4, 1/8.
1, 6.
Anybody want to go with a half? No, look at that. How can it be half? Look at it.
Wait,
Look at it.
one.
If I just cut it in half right
1/6,
there.
I
Oh,
would-
yeah, it is 1, 6.
It's
I would
1/6.
1/6.
It's 1/3 of 1/6. That's why, right?
1/3 of 1
One there was,
I mean 1/3 of a half.
Yeah.
Because if you cut it like that, it's half, right? But that's a
it's hard to
prism,
visualize.
and a pyramid is 1/3 of a prism. That's why, right? So it's 1/3 of 1/2, which is 1/6. There you go. That's how you find the area of a tetrahedron. You just do the parallelepiped thing and then divide it by 6. Is that answer correct, Joe?
Yeah, I got that.
Yeah. Okay. Yeah, I'm gonna fix this and I'll send it out.
Yeah.
Last chance for questions.
Actually, test question.
Because some of you guys just reading these problems for the first time now, that's why, right?
Yeah.
No, actually.
You guys not even ashamed about that anymore. Huh?
What else did you pick through?
Okay, we're done. I'm gonna send these out.
That's study
Time to do-
questions.
I don't think I have enough time to do descriptions.
You're just gonna leave it like?
Yeah, there's only
No,
like
I meant
3
like,
minutes
no.
left in class.
No, I'm not gonna take